Hey everyone, welcome to this explainer. Today, we're diving into how a totally new generation of HVAC technology is completely reshaping how we think about building design. We're looking at a system that honestly might look perfectly familiar from the outside, but what's happening on the inside? Well, that is an entirely different story. So, let's just jump right in with a massive question that engineers, architects, and facility managers have been struggling with for years. For the longest time, the industry has had to make a tough choice. Do you go with the incredible zoning flexibility of a variable refrigerant flow, or VRF system, or do you stick with the inherent safety and simplicity of traditional water-based systems? But what if you didn't have to compromise? What if you could get the best of both worlds in one unified design? That is exactly the promise of hybrid VRF systems, and it's exactly why we're dissecting this technology today.
To get a grip on how this all works, here's our blueprint for today. We'll be walking through 1. The best of both worlds, 2. The outdoor unit, 3. The hybrid branch controller, 4. Safe indoor water piping, 5. Installation and controls, and wrapping it up with 6. The future of HVAC.
All right, let's kick things off with Section 1, the best of both worlds.
The core difference here? It's honestly night and day. With a standard VRF setup, you are pumping large volumes of refrigerant all throughout the occupied spaces of a building. And that brings up a ton of regulatory and safety concerns, especially when you look at newer building codes. This hybrid approach, though, completely flips the script. It keeps all that complex, heavily regulated refrigerant contained far away from your living spaces and swaps it out for safe, simple water for the indoor delivery. It fundamentally alters the safety profile of the entire building.
Moving right along, let's step outside for Section 2, the outdoor unit.
This component is literally the heart of the whole system. Acting just like a traditional VRF heat pump, this is where your heating or cooling is actually generated. It uses refrigerant to absorb heat from the outside air in the winter or dump heat into the outside air in the summer. But here's the absolute game changer. It's connected to the building's interior using just 2 refrigerant pipes, exactly like a typical split-system heat pump. The amount of refrigerant in the entire setup is strictly limited to the distance between this outdoor unit and your mechanical area inside. And sure, there are rules for allowable distances, but they can reach hundreds of feet, which is honestly perfectly fine for most commercial and residential applications.
Now let's head inside to the mechanical room for Section 3, the hybrid branch controller.
Okay, pay attention to this part, because this component is the absolute star of the show. This controller acts as both the brain and the bridge of the entire operation. Inside this very specific component is where the refrigerant safely transfers its heating or cooling energy directly into the water. To make this magic happen, the hybrid controller actually houses 2 small pumps, specifically dedicated to serving the hot and cold water loops. This right here is the exact boundary line. It's where the refrigerant stops and the water begins.
If we follow the energy, it's a super clean, logical flow, like a perfectly choreographed relay race. You start at the outdoor unit, where the refrigerant generates the energy. Then you pass the baton in the mechanical room at the hybrid branch controller, where that energy safely transfers to water. Finally, you reach the indoor fan coils, where the water actually delivers the climate control into the room. It totally isolates the complex chemicals right to the mechanical zones.
Which leads us perfectly into Section 4, safe indoor water piping.
Look at the sheer simplicity of this. Since we are using water now, you've got options. Piping can be run in standard copper or even polyethylene, depending on the manufacturer. But the real kicker is the comparison. You only need 2 pipes running between the branch controller and the fan coil. If you were doing this with a traditional chilled and hot water system, you'd be running 4 pipes. That means double the piping, double the welding, and double the installation headaches. Going hybrid cuts down your installation complexity and your material costs massively compared to those bulky old 4-pipe setups.
And by keeping those indoor spaces completely refrigerant-free, it's a huge win. You are instantly dodging major regulatory headaches and significantly lowering those rigorous leak detection requirements that come with running refrigerants through occupied areas. But wait, it gets even better. Because the hybrid branch controller supports simultaneous heating and cooling, it unlocks a brilliant recycling story. You can literally take the waste heat recovered from a room being cooled and move it instantly to offset the heating demands in another zone. It acts just like an advanced traditional VRF system, but it does it entirely with water.
From there, that heated or chilled water gets delivered straight into your specific zones. And you're not locked into just one way of delivering that air either. This water-based system is incredibly adaptable and fully compatible with all the standard indoor units you're used to seeing. We're talking ceiling cassettes, wall-mounted fan coils, and even concealed ducted units. It gives architects and designers total zoning flexibility with absolutely zero aesthetic compromises.
So, how do we actually put this all together? Let's check out Section 5, Installation and Controls.
Knocking out the mechanical requirements, you've got to be pretty precise. For the main water supplied to the branch controller, you're going to need a strainer, a shutoff valve, and a pressure-reducing valve. Now, since we are heating water, an expansion tank is completely non-negotiable, and this is absolutely crucial. It must be mounted at or above the height of the hybrid controller. Electrically, you're looking at 208 to 230 voltage power across the board for the controller, the outdoor unit, and the fan coils. Oh, and don't forget your drain lines. You might even need internal condensate pumps to lift the liquid up and out to the main line, especially if you're using those wall-mounted units.
Now, when you're actually laying out the space, you get some really cool grouping options. The hybrid branch controller lets you connect up to 3 fan coils together on a single port. But there is a catch. All of those grouped zones must share a similar thermal profile. Because there's only one set of pipes carrying either hot or cold water out of that single port, all the connected zones have to operate in the exact same heating or cooling mode at the same time.
So how do you manage all this hardware? Well, the control wiring is elegantly daisy-chained, kind of like a standard VRF system. Each thermostat wires directly to its respective fan coil. Those fan coils are then daisy-chained together all the way back to the hybrid branch controller. And finally, the branch controller is wired straight to the outdoor unit. This unbroken chain lets the outdoor unit discover and communicate with every single connected component seamlessly. And hey, if you need centralized oversight, it's super easy to wire a master facility controller from the building's main office straight back to the outdoor unit.
Let's take a step back and look at the big picture in Section 6, the future of HVAC.
This quote really hits the nail on the head. Think about it. For decades, we've treated VRF systems and traditional chiller boiler systems as two totally separate design philosophies. Hybrid VRF bridges that gap. It gives you the incredible energy efficiency and the luxury of simultaneous heating and cooling, all while making the indoor installation so much easier and completely risk-free when it comes to refrigerants for the folks actually living or working inside.
It's an undeniable leap forward in structural safety, installation efficiency, and pure climate control tech, which leaves us with this final, really provocative thought to ponder for your next major design project. As safety regulations continue to tighten up all over the globe, how will the inevitable shift to zero indoor refrigerant reshape the future building codes and architectural designs you work on? Because honestly, it's not a matter of if the industry adapts, it's when. Thanks so much for joining me on this explainer, and I'll catch you on the next one.